Welcome to AC BTech, your guide for BTech and beyond. The today's topic we will discuss regarding how the Zener diode can act as a voltage regulator. Very important topic. Okay, students, we will go through it. Zener diode as a voltage regulator. How the Zener diode can act as a voltage regulator, that we will see. Okay, when Zener diode is operated, when Zener diode is operated in reverse bias, the voltage across the diode remains constant, but current through the current through the diode increases or decreases, but the voltage remains constant. To act as a voltage regulator, Zener diode is operated in reverse bias. Reverse bias only. Okay, to act as a voltage regulator, Zener diode is operated in reverse bias only. What are the other names? Zener diode. Zener diode is known as reverse bias diode, or breakdown diode. It means the diode gets operated in a breakdown region. Now generally you can see voltage regulations, voltage regulator using Zener diode. Now this voltage we will call as a line voltage or via source voltage, and the resistor, source resistance. The diode is operated in reverse bias. This is Zener diode, negative positive, is connected in reverse bias. This is a load resistance RL. Now current through here is IS, and the current through this diode is IZ, and current through this load is IL. Current through this load is IL. Now you can see this is a circuit diagram. Now you can clearly see this Zener diode regulator classified two types. Number one, line regulation. Second one is load regulation. Line regulation, load regulation. Okay, before going this, you can see from the previous network. Now it is a circuit. Now what is the total current? What is the total current here? The total current is Is. We can write Is is equal to Iz plus IL. Okay, from this diagram, the total current we will write Is is equal to IL plus Iz. Now from this, if you want, write if IL max, if the load current is max, when IL is maximum, when RL is minimum. When RL is minimum, IL is maximum. We will write IL maximum is equal to Is minus Iz, and this Iz is minimum. Okay. Now from the same relation, if Iz maximum, current through the Zener diode is maximum when Is minus IL. Is it clear? Is minus IL. Now it means almost IL is 0 now. IL 0 means RL is maximum, belongs to infinity. Okay, then you can write Iz max is equal to Is. Is means source current. This Is we can write as, from the diagram, you can see from here we can write Is. Is is equal to Vs. Here the Vs minus the voltage across the diode, this loop. Is here. We can write Is is equal to Vs minus Vz by Rs. Remember, Is is equal to Vs minus Vz by Rs. We simply write from here. Iz max is equal to Vs minus Vz by Rs minus IL. Okay. Therefore, the total power in the Zener diode, total power in the Zener diode, we will write as Pz max. Pz max is equal to, we know that P is equal to V into I. That is the total power maximum is equal to Vz, voltage across the diode, into Iz. Iz max. This is the maximum power rating. Maximum power rating. Maximum power rating of the diode. And units of diode, it's watts. Power unit is watts. Okay, this is about a general overview of the power through the Zener diode. Now we will say regulation characteristics, line regulation. Line regulation. What is a line regulation? Line regulation is nothing but line regulation. Line regulation is nothing but, now what happens? The line voltage changes or fluctuations, the line voltage changes or fluctuations takes place, but the output voltage across the diode across the diode will remains constant. Okay, the line voltage changes or fluctuations takes place, but the output voltage across the diode which remains constant. That is, output voltage V naught is equal to Vz. V naught is equal to Vz. Now you can say, in the previous also we have seen, Is is equal to Vs minus Vz by Rs, or we'll write Is is equal to Iz plus IL. Now you can see here, as line regulation means line voltage increases, Vs increases. As Vs increases, now you can see here, Vz is fixed. As Vz increases, Is increases. But V naught is equal to Vz remains constant. Remains constant. Line regulation means as the line voltage increases, Vs increases. As Vs increases, Is increases. But V naught is equal to Vz. There is no effect in the voltage drop across the diode. That is why the output voltage across the diode which remains a constant. That is a line regulation. In this line regulation, we can keep by keeping load constant. Load constant. This is about line regulation characteristics. Now we will see load regulation. Load regulation. In the load regulation, what you can say? In the load regulation, by keeping input line voltage constant, keeping line voltage constant, if load resistance, if load changes, output voltage remains constant. Output voltage remains constant. That we will see now. That is, as you can say, that is 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 equal to Iz plus IL. Now you can say, as RL decreases, if load resistance decreases, then what happens? Current is IL is maximum. IL is max. That is, we will write Is is equal to Iz minimum plus IL maximum. Okay, IL maximum. IL maximum. It means the total current can be shifted in this. Suppose it is always the current through the diode cannot minimize than the Iz minimum. Is it clear? Then IL maximum, then Iz will be minimum. Iz will be minimum. But the voltage remains constant. Voltage remains constant. Here you can clearly understand that current through the diode increases or decreases in line or load regulations, but output voltage remains constant. Output voltage remains constant. Output voltage remains constant. This is a line and load regulations of a Zener diode. Okay, students, we will see a small example. A Zener diode has a breakdown voltage of 6 volts, a breakdown voltage of 6 volts and knee current of 2 milliamperes. 2 milliamperes. Calculate the value of resistors, the value of resistance and output voltage remains constant. Output voltage remains constant of 6 volts and calculate maximum power rating. Maximum power rating. Okay. Now we will see, and the given circuit is as given here 10 volts, it is 20 ohm, here diode is voltage across the diode is 6 volts and here the load resistance R you have to find and the load here is IL. The current through the Zener diode is IZ. Here it is IS. It has a given. Now to find this, first you can see what is the total current. In this loop equation, it has given 10. You can find out the current IS. IS is equal to Vs minus Vz by Rs. Is is equal to Vs is source 10. 10 minus 6 by 20. Oh. What you are getting? You are getting 4 by 20. 4 by 20 means 2 by 10. 1, 2, 5. 1 by 5 means 0.2. 0.2 amperes. You will get Is as 0.2 amperes. We will write this 0.2 as 200 milliamperes. We can write this Is as 200 milliamperes. Okay, students, as given. Okay, from here we find the value of Is. Is is 200 milliamperes. Okay, next we given knee current. Knee current means minimum current in the breakdown. Before entering into the breakdown region, knee current. Now it is a reverse bias. Okay, this minimum current is called as a knee current, bending. This portion we will call as a knee current. This is voltage, breakdown voltage, and it is Iz minimum. This Iz minimum is known as a knee current. Knee current. Now we will write a knee current, that is, therefore, Is is equal to Iz plus IL. Now we have seen this, that is, if Iz max is Is minus IL minimum. IL maximum is nothing but Is minus IZ minimum. Okay. Now from here we will find out the IL maximum, because IL minimum given knee current it is. Knee current how much he has given in the problem? 2 milliamperes. Now we will write IS is 200 in minus 2 milli, and you will get 198. 198 milliamperes, that is IL max. The maximum load current. The maximum load current is this much. Now we will find out the resistance. R is equal to output resistance by output current IL. Clear? What is the output voltage? Voltage across the diode will remain same, V naught, across the from the circuit diagram. Now you can see here, this is IL. IL means here the voltage is VZ. The same in parallel network shunt, we will call it as a shunt regulator, because load resistance is connected in shunt with the diode. Now here also the voltage in parallel will remain with VZ is nothing but V naught. V naught is equal to VZ. That is why we will write IL. IL is equal to uh, V naught or V naught by RL. If you write RL, RL is equal to V naught by IL. Okay? Okay, students. Therefore, we will write R is equal to V naught by IL. We have IL maximum, that is IL maximum. We will write R minimum, RL minimum. This V naught is 6. 6 by 198. 6 by 198 milliamperes. 6 by 198 milliamperes. Then it will come like a 600 by 6000 by 198, because milli will becomes a, when it goes up it will becomes a milli will becomes 6000 divided by 198. Okay, because kilo will go, milli will go up, then it becomes 1000. 600 by, you will get a 600, 6000 divided by 198. It becomes a approximately how much? 30.3 ohm. Okay, you will get RL minimum is V naught by IL max 6 by 198. This approximately 30.3 ohm. 30.3 ohm. Now if you want to write a minimum power handling, through the diode. Okay, now we'll got these values, and if you want to find IL, IZ max, you can clearly see here, IZ maximum is nothing but IS minus IL minimum. IS minus IL minimum. IZ max is equal to IS minus IL minimum. Now IZ max is equal to IS is 200 milliamperes minus, if IL minimum is 0, if IL is minimum 0, when RL is maximum up to infinity load current is 0, then IZ maximum is 200 milliamperes. Now the maximum power handling, that is PZ max is equal to VZ into Ij max. We will write Vz is 6, Iz is 200 milli. Now 6 to the 1200. 1200 milliwatts. 1200 milliwatts or 1.2 watts. What is the maximum power handling? 1200 milliwatts. This is the power through the diode. Power handling through the diode. Okay, students. Easy BTech guide for BTech and beyond. Easy BTech guide for BTech and beyond. Thank you.